Now see, we have a wire, find the magnetic field at point P. So a wire is coming out like this, you can see the pen nib, and the one wire is going down. And for this we have to find out the magnetic field at point P. And this is an equilateral triangle. Now, if I concentrate first of all on this wire AB, I'm going to use local vectorial method to find out the direction of magnetic field. What do you mean by local? For this wire, I'll assume this as the XY plane. This is X, this is K cap, and upward will be J. And when I come to this wire, then this will become minus K, and this will become minus I. See, this was X axis, no? This was, so for every wire I'll have a local XYZ. So I'll be using a local XYZ method to find out the direction of magnetic field, and many other questions I'll be using the same. Means if I'm talking about only this wire, then this is X axis, this is Y axis, this is upward is Z axis. But I'm talking about this wire, then this will become it is downwards. The wire is downwards, so I'll have you to take current direction as minus K. Now if I'm taking this point as the wire, XYZ axis will be like this, that upward is plus K, this will be obviously plus J, this is plus I, and this left will be minus I. This I will be using. Okay, so please don't confuse yourself, sir. While you were taking this wire, this was plus X. No, this is plus X. How is it possible? No, when I'm solving for this, these directions only work till here, work for this this situation and this position. When I'm taking this point as the concern, then my XY axis will again be taken into consideration, new XY axis, and I'll solve accordingly. Okay, that will help me to find out the direction instantly. Now, so first I'm solving for this wire A. It is coming out, so current, we know that it's infinite wire. For infinite wire, the answer is, for infinite, I've already told you the answer is Ki by A in distance into 2. Okay, so already I've written that formula, Ki by L, because L is given to us in the question. But then what about direction? Direction easy, very easy calculated. That the current is plus K, and the point of interest is right. So if this is plus K, this is right, this is called I cap. So I've taken K cross I. So K cross I is J. We're done with the A. Now let's talk about, and the direction is, see what is the direction? That is J. And if this is Y axis, I have got this BA. Now obviously, since it's a result of cross product, it will be perpendicular to the two vectors. That what are the two vectors? The current carrying wire as well as the position vector. Now current carrying wire is not in the plane of paper, it is outside, so we cannot see it. Okay, but we can obviously see this position vector. So for it, the angle must be 90, and hence this BA is 90 degree to this distance called L, or you can write AP. Okay, now this is angle is 60 degree given to us. So if I break it, it will be 30. Then this will become 60. And since B is 90 degree and 30 is this, 60 it is this, then this becomes 30 again. And this magnetic field is at an angle 30 with this horizontal. Okay, so that is what I have drawn here. BA I have got, and this is 30 degree. So one component is going to be towards the left, and the one component is going to be at the top. Okay, now this is done. Now we'll go to the second wire B. The formula will be same, Ki by L2, but this wire is going inside, which is minus K cap, and left to it is taken to as minus I, because when I'm thinking of a XYZ frame, this will be the XYZ axis, this is Y, this is X, and outside it is plus Z. Left side it will be minus X. So I have taken obviously minus I. So formula as it is for infinite wire. Then the current is going inside, and you have to take the point left to this point, that is minus I. So I'll get minus gets cancelled, and K cross I is already J. So now we have the two magnetic fields. You can also see that this and this gets cancelled because they are going to be come out to be same. Okay, so X component means cos 30 component will get cancelled, and you can simply add the sin 30 components. Instead of that, what I have done is, instead of thinking about what cancels what, these two vectors are at an angle at 120 degree. So I have simply added two vectors at an angle of 120 degree, and how both the magnetic field are same. For the time being, I have written b square 2ab cos 120. Now cos 120 is minus half. So this cos 120 cuts 2, bring the minus sign, so b square gets cut as well, and ultimately answer is B. And we should also know that magnetic field at two vectors if added at 120 degree and they are equal value, then the resultant is also of the same value. Okay, that means a plus a at 120 degree gives me a only. So if you remember this, then you can directly write B, and then we can find the answer B as we have already written 2ki by L, and the direction is vertically upwards because this is the direction in which they will be added by parallelogram law of vector addition, and that is the answer to the question.